Hi Rockridge, this is Mrs. Berger, and today we're going to learn about multiplying and dividing rational expressions. As a side note, this is absolutely my favorite lesson of the year. It's so much fun. I hope you agree. So let's launch right into today's lesson, multiplying and dividing rational expressions, or polynomial expressions. The key to today is two simple things: factor and cancel. So if you have great factoring skills, you're going to love today. If you could brush up on those skills, today's a good chance to get that extra practice. Okay? So to simplify this rational expression, or this polynomial rational expression, what we're first going to do is factor each of the polynomials. Now we've got a quadratic and a quadratic. Let's go ahead and factor each of them. So let's look at the top here and think what multiplies to negative 12 and adds to negative 4. So think about that for a moment. Hopefully you came up with 6 and 2, and you need the 6 to be the negative and the 2 to be the positive. So there are your factors for the top. Now let's look at the bottom. What do we have here? We have x squared minus 4. Can we factor this? Hopefully you see that that's a difference of squares, and that you can factor that to x plus 2 and x minus 2. If you wrote these, the orange or the blue, in a different order, that's completely fine. Now, we've done factoring. Now let's do the canceling. This is my favorite part. If you see it up top and you see it down below, you can cross it out. Just like if you saw a 2 over 2, you could cross that out to be 1 over 1. We're going to cross out x plus 2 and x plus 2, because that cancels out to be a 1. And so the simplified version of this is x minus 6 over x minus 2. And for once in our Algebra 2 lives, the instructions simplify actually end up with something simpler than what we started. I absolutely love today's lesson. Things get nice and canceled out and nice and simple. A couple of notes to warn you against. Make sure that when you get to here, you don't see this x over x and cancel that out, or the 6 over 2 and cancel that to be 3 over 1. Treat these factors as entire entities. You may not break them apart for cancellation purposes. If you see a whole factor match a whole factor on the bottom, you can cancel. Otherwise, do not break these factors apart. Leave them as is. So let's take a look at number 8 here. The factorization of this actually depends on a GCF this time. Remember, we should always be looking for a GCF first. So the GCF here, the greatest common factor that we can find here, is 2x squared. And we will leave behind 4x minus 1. If you didn't quite follow what just happened, how we got down to 4x minus 1, pause the video and think about dividing 8x cubed by 2x squared, and then dividing 2x squared by 2x squared. You leave behind a 1 here, a negative 1 here, not a 0. They cancel out and leave a 1 behind. So make sure you're nice and clear on how that worked. Again, on the bottom, we have another situation with the greatest common factor. I see an x within there, and I'll leave behind a 4x minus 1. Again, think about, when you say the greatest common factor is x, think about dividing this by x and dividing this by x and leaving 4x minus 1 behind. Now my favorite part, let's cancel things that we see that are in common. This whole factor and this whole factor are the same. X squared and x, I'm going to cross out this x here and drop this degree 2 down to a degree 1. So my final simplified version is 2x. Look how much simpler that is from where we started. Absolutely beautiful. Now that was simplifying a single fraction. What if we're multiplying two fractions together? Well, if we're multiplying two fractions together, the same rules apply. Factor and cancel. This time, if you see it anywhere on top and anywhere on bottom, you can cancel. It doesn't matter. It doesn't have to be in the same fraction. As long as one's on top, one's on bottom, you can cancel. So let's first do our first step, factoring. I see a GCF situation here again. So I'm going to take 4x outside and leave behind x minus 1. Pause anytime if you have questions about how I got any of these. Now let's move to the bottom left and factor this. what multiplies to -3 and adds to +2. Hopefully you realize that 3 and 1 are really the only choices you have, and in this case the 3 has to be positive and the 1 has to be negative to make it work. Alright, let's continue our factoring work. Let's do the top right. What multiplies to -6 and adds to +1? Hopefully you came up with a 3 and a 2, and the 3 has to be positive and the 2 negative. And then on the bottom here, this 4x really doesn't have any work to be done. He can't be factored. Now my favorite part, let's cancel. I see a 4x and a 4x. I see an x plus 3 and an x plus 3. I see an x minus 1 and an x minus 1. Hopefully you saw that even though this was in this fraction and this was on the other, he's on top, he's on bottom, they cancel. Top, bottom, cancel. Top, bottom, cancel. All we're left with is x minus 2. And you can put parentheses or not. I tend to over parentheses these things. Look how much simpler that is than what we started with. Absolutely love this lesson. Now let's look at another multiplication. If you see the dot here or a giant multiplying x here, we're trying to multiply these two fractions together. And the best way to multiply two fractions together is to simplify them first. So let's think for a moment here. We've got a non-1 sitting in front of here. So we're going to think of what are factors of -6 whose sum is -1. I think I need 3 and 2 of some kind, and that 3 needs to be negative. So now let me reduce this to 1 and 1. So here, the factorization of that is 2x minus 3 and x plus 1. Now let's move to the bottom here. I see a GCF, and I'm going to take that out. I'm going to leave behind an x plus 1. I see another GCF up in this upper right-hand corner. I'm going to pull that out and leave an x plus 1 behind. If any of this factoring work is going too quickly for you, pause the video and make sure you follow along how I did that factoring. And then this bottom right-hand part is its own factor. It can't be factored. Now my favorite part, the canceling. You could either cross this x plus 1 and this x plus 1 out, or this blue one and this orange one. But do one and only one, and make sure one is on top and one is on bottom. Make sure you don't cross out the two tops. Those don't cancel, only if one appears on the top and one appears on the bottom. I also see this x that can be canceled. One's on top, one's on bottom. And now I caution myself, if I have a 2x minus 3, that is not the same as 2x plus 3. So I may not cancel those. Those are not the exact same thing. So my most simplified version of this is 2x minus 3 on the top, x plus 1 on the top, and 2x plus 3 on the bottom. Do not cancel these 2's, don't cancel these 3's. Treat these factors as their own entity. Unless they match, you can't cancel them. So that was simplifying a multiplication problem. And again, rational, think fractional, rational, fractional, rational, fractional. So we've got fractions here. These rational expressions are fractions of polynomials. All right, so that was simplifying a single fraction, multiplying two fractions. Now let's do the last part of today, which is dividing. Remember when dividing, remember back in elementary school, when you were dividing two fractions, you need to multiply by the reciprocal. So just like in elementary school, we're going to, instead of divide, we're going to change this divide into a multiply by the flip, by the reciprocal. I'll see how that happens. So this first fraction does not change. It stays the same in a division problem. It's the one that comes after the division that we flip. So let's turn this divide into a multiply, and let's flip the fraction. X squared minus 6x plus 8, and then x squared minus 2x goes to the bottom. Now that we've got a multiplication problem, we do what we did on the last page. We factor and cancel. So this one on the left here, nothing to do there. Let's pull a GCF out of here, GCF of 3. Things that multiply to 8 and add to negative 6. Multiply to 8 and add to negative 6. Hopefully you came up with some version of 2 and 4, and both of them have to be negative. On the bottom here, we've got a GCF situation. Let's pull the x out and leave behind an x minus 2. If any of that factoring work went too fast for you, pause the video and make sure your work matches so that you can do these on your own. All right, let's go ahead and cancel. Now that we've factored, let's go cancel happy. So x minus 2 on top, x minus 2 on bottom. X minus 4 on top, x minus 4 on bottom. X and x. Make sure you don't cross out this 2. That did not get crossed out, just the x part. So I'm left with 2 over 3. Look how pretty and simple that is. It's just so pretty. Everything else canceled and we're left with just the 2 and the 3. Don't forget to get those GCFs. That's how we got down to here. Pulling the GCFs out was the best way to get down to 2/3. Number 12, it's phrased a little bit differently than what we've been seeing. We're not actually given two fractions right off the bat, but you and I both know that that x minus 1 is actually the fraction x minus 1 over 1. Okay, so keep that in mind as you work this one through. This fraction stays the same, top and bottom, and we flip what comes after the division sign. So we're going to turn this from division into multiplication, and we flip the fraction. So now that 1 is on top and the x minus 1 is on the bottom. Now let's factor and cancel. What multiplies to positive 2 and adds to negative 3? Some version of 2 and 1 clearly, and it looks like both of them need to be negative. Nothing to be factored on the bottom there. Nothing to be factored here, and nothing to be factored here. So that was fairly quick. Now let's do our cancel. Cancel the x minus 1 on top, cancel the x minus 1 on bottom. And I don't think I see anything else that can be canceled. I may not cancel these. They are part of two factors that are not the same. I may not cancel the 2 and the 4. These parentheses are blocking me from doing that. So my final simplified answer is x minus 2 over 4x squared. That's as simple as I can get it. Not as pretty as 2/3, but we'll take it, especially compared to what we started with. All right, again, 13, they didn't give us two fractions, but you and I both know that this right now is 2x minus 3 over 1. So let's treat that as such. So 2x minus 3 over 1 does not get flipped. He stays as is. The thing that comes after the division sign is what gets flipped. So instead of dividing, let's change it to a multiplying of the flip. X plus 5, you move to the top. 4x squared minus 9, you move to the bottom. Now let's factor and cancel. Nothing to factor here, so let's just rewrite it. Nothing to factor up top. On the bottom, I have another difference of squares. 4x squared is a perfect square, and 9 is a perfect square. So a squared minus b squared gets factored to a plus b and a minus b. So 2x plus 3 and 2x minus 3. Now that I've canceled everything, now that I've factored everything, I was all excited about canceling. Now it's time to cancel. I see a 2x minus 3 on top and a 2x minus 3 on the bottom. Make sure you grab the right one. Make sure you grab the matching one and not the plus 3. And I don't see anything else that can cancel. So the most simplified version is x plus 5 over 2x plus 3. If you need to put a 1 in front, that's fine. You don't need it though. So that's the most simplified version. 14. We have a fraction divided by a fraction. So let's first write that as 3x minus 1 over 2x cubed minus 2x. That doesn't change. Turn the division into a multiplication and flip the fraction. 2x cubed minus 2x squared over x. Now, before you get too excited about canceling this top and bottom, notice that they are not the same thing. So don't do any canceling until you know you've got the same things. Let's factor before we cancel. The 3x minus 1 doesn't get factored, but the bottom here does in fact have a greatest common factor. It's got a GCF, and that GCF is 2x. Let's leave behind x minus 1 times the GCF here is 2x squared. And we're going to leave behind, oh, I'm sorry, this is, my apologies, I missed a squared there. I pull the 2x, I leave behind an x squared minus 1. The GCF here is 2x squared, so I leave behind x minus 1 over x. Now, take a look again. We actually have not fully factored everything. Notice this x squared minus 1 can be factored again. And since I'm running out of a little bit of room here, I'm just going to go ahead and cross this out. This is another difference of squares, just like we saw over here. Something squared minus something squared. Once again, we have a difference of squares. So let's further factor that into x plus 1 and x minus 1 on the bottom here. If you need to rewrite the whole thing instead of saving space, that's fine. I'm just trying to save space here. So now that I have this fully factored, now I'm going to start crossing things out. So this x minus 1 and this x minus 1 cancel. This x and this x can cancel. I'm going to bring him down to a power of 1. This 2x and this 2x cancel out cleanly. And I'm left with things, this 3x minus 1 and this x plus 1 cannot cancel. So that's what I'm left with. 3x minus 1 is left on top, and x plus 1 is left on the bottom. If ever you get to this purple step and you see more things that can cancel, that's completely fine. Just go ahead and keep on canceling until you get down to the most simplified version. If you need to do it in a couple of steps, that's not a problem at all. All right. Let's do a little bit more practice, sort of mixed practice. We need to make some decisions as we come across each of these problems. So for number 15, we actually don't need to factor any of this. We just see common terms here that can be canceled out. If you would like to multiply first and then cancel, that's completely fine. I love canceling before multiplying so that I'm dealing with smaller numbers. Either way is completely fine. Let's go ahead and multiply first. So let's see what we have here. We have 120. X to the 5th times x is x to the 6th. And then there's a y to the 1 up there. And then down below we have 5, x to the 3rd, y to the 4th. Now let's cancel what we can. So a 5 and a 120 go neatly into a 1 on the bottom and a 24 on top. X to the 3rd and x to the 6th simplifies down to an x to the 3rd on top. Or if you think of this as 6 minus 3, since that's on the bottom, that's fine too. Y to the 1 and y to the 4th gets down to y to the 3rd. If you need to do this in multiple steps instead of crossing out, that's completely fine. But your most simplified answer is 24 x to the 3rd over y to the 3rd. That's the simplified rational. That was a multiplication. Caution here, we have a division. So let's make sure we do the flipping. This stays the same, 8x to the 4th, y to the 3rd over 16xy. Instead of dividing, we're going to multiply by the flip. 4x to the fourth y squared moves up there. 5x to the third y comes down there. Had you not flipped, you would be canceling things that you weren't supposed to be canceling. So make sure you pay close attention to this division sign. Don't do any canceling until you've multiplied by the flip. All right, now we can multiply. 8 times 4 is 32. X to the fourth times x to the fourth is x to the eighth. Y to the fifth over 80. X to the fourth y squared. Then this simplifies. 32 and 80 can get down to 2 over 5, I believe. 2 and 5. So you're left with 2 x to the fourth y to the third over 5. I took 8 minus 4 and 5 minus 2 and left with positive exponents up here. If any of that went too fast, go ahead and pause the video and make sure you followed how that happened. 17, we're back to these rational polynomials, these rational expressions here. I've got a division, so I know I'm going to need to multiply by the reciprocal. Let's first make sure that we know that originally this is x plus 2 over 1. So when I flip it, that 1's going to pop to the top. I'm going to go ahead and save myself some room. Before I write this down, I'm going to factor it. So multiplies to 4, adds to 4. That must be x plus 2 and x plus 2 over x plus 3. And again, just saving myself some room. If you don't want to do that, that's fine. Instead of dividing, I'm going to multiply by the flip. Now, the caution here is only cross out a 1 for 1. If you see 1 on the bottom, only cross out 1 on the top. Don't cross both of them out. So your final on this is x plus 2 over x plus 3. Look how simple that is. Oh, it's so pretty. So pretty. For 18, again, think of this as this polynomial is sitting over top of 1. So remember that as you're going through. And again, I'm going to save myself some room. I'm going to go ahead and factor this. I see a difference of squares here. So I'm going to factor that into x plus 1 and x minus 1 right off the bat. I'm not doing any flipping because that came first. Now, instead of dividing this fraction, I am multiplying by the flip. Then I get to do my fun canceling. I see an x minus 1 here and an x minus 1 here. Make sure you grab the right one. Don't accidentally cross out the x plus 1. So your final on this is x plus 1 times x plus 5. It is over 1, but I'm not going to bother to write that. I don't need you to FOIL this back out and give me a quadratic in standard form. Just know that if you were ever to see a multiple choice question for the answers to 18, you would recognize, if you saw a standard form of this, you would recognize, oh, that's the same as my answer. I just have it factored, and the answer choice is in standard form. But I don't need you to do standard form for this. This is fine. All right, last couple of practice problems. 19 and 20, and I kind of call this the boss level for my classes. For our purposes right now, I would like you to treat this like it has a bracket around it, just so that we don't get confused with PEMDAS. So what we're going to do here is we're going to take this polynomial and divide this rational, and then following that, we'll multiply it by here. Okay, so just to be very clear, that's what's happening. Once again, anytime you see a fraction situation or a rational situation, know where things are standing over top of 1 to begin with. All right, let's get to it. Let's get to our factoring and canceling. So for this guy, again, I'm going to go ahead and factor it. What multiplies to negative 30 and adds to 1 It's got to be some version of 6 and 5. It's got to be x plus 6 and x minus 5. And as we said, that's over 1. Now, after the division sign, I'm going to multiply by the flip. And again, to save myself some room, at this step I'm going to go ahead and factor the flip. So what multiplies to 12 and adds to 7? I'm thinking 3 and 4. So the 3 and 4 factorization, instead of being on the bottom, I'm going to write it on the top since I'm flipping it. If you need to do this in more than one step, that's completely fine. So that you don't mess yourself up, that's fine. I'm just trying to save some room. So the factorization of the bottom is popped to the top. Now the factorization of the top is going to be moved to the bottom. So what do I have here? I have things that multiply to 30 and add to negative 11. It's got to be some version of 6 and 5. It's got to be both negative. Alright, so that took care of the division. And now multiplying, there's really no factoring to do, so I'll just copy it down so that I can see where everything is sitting. So that's x minus 6 and x plus 6. Now let's do the fun part of canceling. If I see it on top and I see it on the bottom, I can cancel. So I see x minus 5, x minus 5, x plus 6, x plus 6, x minus 6, x minus 6, and I'm just left with x plus 3 times x plus 4. And again, I'm not going to FOIL this back out. I'm not going to put it over 1, but if you want to, that's completely fine. Alright, hopefully this is coming a lot easier for you by now. So let's take a look at our last example. Let's go ahead and factor this before we write it down again. So I see here that I've got a common factor. I see a greatest common factor of x. So let's do x times x plus 11. And the bottom doesn't get factored. This, I know, is sitting over 1 right now. So when I divide it, I'm going to multiply by the flip. And I'm going to go ahead and factor while I'm sitting here. So I see a GCF of 3x, and that's going to leave behind an x plus 2. Then I look at this, I'm multiplying, so no flipping has to happen. I see a difference of squares here that can be factored to x plus 2 and x minus 2. And I see an x plus 11 that can't have anything done to it. And now the fun part. Let's see. I see an x plus 2 and an x plus 2, an x minus 2 and an x minus 2, an x plus 11 and an x plus 11, and an x and an x. Be sure you don't cross out this poor little 3. And I'm left behind with 1 over 3. Look how simple that is. Look what we started with, and look at how simple our answer is. I love all the canceling. Alright, so that's your guided practice. Go ahead and attempt your homework for tonight. Make sure you check your work against the key and come to class with questions.